Hi everyone, so today I'm going to show you guys or remind you guys how to graph log functions from the parent graph. So from what we have here, we have g of x equals negative log base 2 of x plus 3. And the parent graph is log base 2 of x. So when graphing the parent graph for logs, it's helpful to rewrite it in exponential form. So if it's y equals log base 2 of x and I rewrite it in exponential form, let's do that down here, then it's the same as 2 to the y power is equal to x. So when we have something that looks like this, it might actually be more beneficial that we plug in y values and get x values. So here I'm going to put our usual -2 up until +2. So if I'm plugging it into 2 to the y, then there are also some other rules I need to remember. I need to remember some exponent rules. So if I have a negative exponent, then I'm going to flip it to make it positive. So it's 1 over 2 squared, which is 1 over 4. And if I have 2 to the -1, it's 1 over 2 to the first power, which is just 1/2. 2 to the 0. Anything to the 0 power is 1. 2 to the first is itself. 2 squared is 4. So then that's going to help us get our graph, and it's going to give us these points that are on the graph. So all the points are on the graph now, and we can see as we go to the left, they get closer and closer together, which means there's going to be a vertical asymptote right over here. And that vertical asymptote is x equals 0. Now, if I want to describe the transformation, I might want to remember this little form here, g of x is equal to a times log base b of x minus h plus k. And remember what each of these values do. That a value, if it's negative, it's going to give us a reflection. It can also give us a stretch or shrink depending on what the number is. This h value helps us tell if it's moving left or right. And then this value that's outside being added or subtracted will tell us how much it's moving up or down. So looking at our g of x, I see that there's nothing happening to x inside. So there is no horizontal translation left or right. There is a negative out here. So that tells me that there's a reflection over the x-axis. So I'm going to say to obtain the graph of g, reflect f of x, the parent graph, over the x-axis. Then there's also this +3 outside, which means it is going to be a vertical translation up 3 units. So based off the things that are happening here, if I am reflecting over the x-axis, then the y values are changing. And if it's vertically up 3, the y values are also changing. So the x values are actually going to stay the same. I'm still going to have the exact same x values I had from my parent graph table. So if the first transformation is reflecting over the x, then we are multiplying our y values by -1. So they become 2, 1, 0, -1, and 2. And then if it's vertically up 3 units, then the next thing we're going to do is add 3 to it. So 2 plus 3 is 5. 1 plus 3 is 4. 3, 2, and 1. So then we have some new values that we can plot for our x and y values. 1/4, 5. 1/2, 4. 1/3, 2, 2, and 4, 1. So that we have something that looks like this. And then in this case, there is no horizontal translation. That's the only thing that's ever going to change your asymptotes. So the asymptotes end up being at the same place, also x equals 0. So now that we have our graph, we can go ahead and tell what our domain and range are. So for my parent graph, the thing that really limits my domain is that vertical asymptote. So I'm going to say that my domain goes from 0 up to infinity, because we have 0 here, and then it keeps going to infinity on the right side. And then I can also write it like so. For my range, it keeps going down to negative infinity, and then it also slightly keeps rising up to positive infinity as well. So it's going to go from negative infinity to positive infinity. And the domain and range for our transformed graph g of x actually ends up being the same thing as well, from 0 to infinity for the x values as well because of that asymptote, and the same thing for our y's. Even though it looks like it might not cross that x-axis there, it actually will eventually go further and further down so that it passes it. So it also goes from negative infinity to infinity. Both vertical asymptotes are x equals 0.